All right, so here we've got a um, two proportion z-test. I'll let you pause the video and you can read the context, just so I'm not wasting time on the video. But so we want to carry out a two proportion z-test at the alpha equal 0.05 level. So let's go through the whole process. First thing we're going to do is state what we're doing. So we really want to restate that we're doing a two proportion test. We usually want to say whether it's one-tailed or two-tailed. We want to include definitions for our, well, in this case, for our p values for each sample. And we want to, in this part, give the null hypothesis and alternative hypothesis. So let's go ahead and get after it. The first thing we're going to do is just make a statement about what we're going to do. So our statement looks like this. We'll use a two-tailed z-test, and I just want to highlight the important parts here. Two-tailed z-test. Tell them what kind of test. Tell them the alpha level, and then essentially just give them context. So we're looking for a significant difference in the proportion of teens and young adults that own an iPod or an MP3 player. Next part are the hypotheses. So your null hypothesis looks like that, which essentially states that there is no difference between the proportions of teens and young adults that own an iPod or an MP3 player. The alternative hypothesis looks like this, not equal to zero. So essentially states that there is a difference, and we're not stating whether one is larger than the other. We're just looking for a difference, a significant difference between the proportion of teens and the proportion of young adults that own an iPod or an MP3 player. And then the next thing is you want to make sure that you define some of the notation that you used here. You introduce some notation, P sub t and P sub ya. So we want to make sure that we define what that is for the reader. So that looks like this. So we've got our state step done here, and we want to go ahead and move on to the plan. So under plan, we want to make sure that we check our conditions so that we can actually use inference here. So first condition is that both samples are taken randomly. And we can go back up here to the context and see that both samples are random samples. So random sample of 800 teens, random sample of 400 young adults. Second thing we want to check is that we can expect 10 successes and 10 failures for each one of these samples. So I've got a sample of 800 teens where 79% are going to be successes. So I'm not even going to do the math. I'm just going to say, yeah, that's definitely more than 10 successes. And then 800 teens times the complement of that is definitely going to be more than 10 failures for the first sample. And also for the second sample, we've got 400 young adults, and that was times 0.67. That's also going to be more than 10 successes. And the complement of that times 0.33 is definitely going to be more than 10 failures. If you want to do the math on that, you can. I don't believe that it's necessary for credit here. So these three conditions check out. So we can go ahead and do our two proportion z test. And when we do that, we're going to use our calculator to do that. So I'll go through that sequence here in a second, but we want to make sure that we report a couple things. Number one, our p hat here is not actually a difference between p hat of the teens and p hat of the young adults. This is going to be a pooled p hat. So p hat pooled. And the reason that it's a pooled p hat is because of this thing up here, our null hypothesis. In our null hypothesis, we assumed, or we're operating under the assumption that there is no difference between the groups. And because we're operating under that assumption, we can go ahead and calculate a pooled p hat and run our test based off of that. So this is what it looks like. In the numerator, we're going to add the number of successes, and we've got a little bit of math to do there. So go back up to the context here in the problem. We've got 800, a sample of 800 teens, and out of those 800, 79% are considered successes. So 79% of 800 is going to be 632. And then similarly, we've got to figure out the number of successes for the second sample, the young adults. So that's 67% out of the 400, and that's 268. So we add up our total successes of the two groups, and then we just add up the sample sizes. So the first sample size for the teens was 800, the sample size for the young adults was 400, and all of a sudden we get a p-hat pooled of 900 over 1200, or 0.75 or 75%. So the next step is to use that in order to report what your Z score is for this particular scenario. So the numerator is going to be the proportion from our first sample minus the proportion from our second sample, or in other words, the differences that we found. And we're going to technically subtract the assumed difference of 0 that we assumed up in the null hypothesis. The denominator is where we use the pooled proportion from up top that we just found. So this is how we calculate the Z-score. So this is how the calculation for the Z-score works. Simplified, we get 0.12 over 0.0265, and ultimately we get a Z-score of 4.53, which should kind of jump off the page to you as pretty high here. So a couple things I just want to reiterate here. Number one, you want to make sure that you report under this do step the type of test, and then we want, for this one, the p-hat pooled. So we want to report that. We also want to report this Z-score for this particular scenario, and in order to do that, that's where that p-hat pooled comes in and is used. All right, so to finish up this step, we actually want to run the test, and I'll show you that in the Inspire real quick here. We go to the Inspire, we go to Menu, Statistics, and this is a stat test, so we go down to Stat Tests. And the one that we're interested in here is option number 6, a 2-proportion Z test. So we're going to click on that. It asks us for some of the information that we need, so we go ahead and enter that information here. So there's all of our information entered. So just to highlight real quick, 632 is the number of successes for teens, 268 is the number of successes for young adults, and I did that by just taking 0.79 multiplied by 800 to get the 632, and 0.67 multiplied by the 400 to get the 268. So you do have to enter the actual number of successes here instead of just the proportion or the percentage. Lastly, alternative hypothesis. We've got a two-tailed test here, so we want the alternative hypothesis that P1 is not equal to P2. And we can go ahead and run our test. A couple things to highlight about the output here. Number one, it spits out the Z-score. Here's the Z-score. So you want to make sure that you understand that you don't have to calculate that by hand necessarily unless they ask you explicitly to do that. You can run the test and it'll give you that. Just make sure that you report it as part of your do step. Secondly, obviously, they're going to give you the p-value. That's what the test does. Spits out the probability that you get that result or more extreme. They give you the sample p-hats, which is basically just off of what you entered, but they also give you the pooled p-hat, which is kind of nice. So you actually don't have to show that either. You just have to make sure that you show that you are using a pooled p-hat. So you can just report that pooled p-hat right there. All right, so we're going to take this result from the p-value of 0.000006, and we're going to go back and we're going to make our conclusion based off of that. All right, so you can see under the do step, I've reported the actual test results, and we can now go and conclude. So our conclusion, the first thing you want to do is you want to compare your p-value from your test to the alpha level of significance. So here's what that looks like. With a p-value of 0.000006 less than our alpha level of significance of 0.05, we're going to reject the null hypothesis that there is no difference and conclude that at the alpha equal 0.05 level of significance, there's a statistically significant difference between the proportion of teens and young adults that own an iPod or MP3 player. So a couple quick notes here. Again, you want to make note of the alpha level that you ran your test. Obviously, you need a decision on the null hypothesis. So you either reject or you fail to reject. You want to make a comparison between your p-value and your alpha level, and then obviously include context in your decision.